So we will look at the light questions, MCQs, and their explanation. The strategy is to answer them. Question number 1 about reflection. The angle of incidence is this. It is the angle that the incident ray makes with the normal. Normal is a perpendicular imaginary line perpendicular to the mirror where the reflection is taking place. And R is the incident ray, reflected ray that makes with the normal. Question number 2. The focal length of a lens, converging lens, is where the ray coming from the object parallel to the principal axis after passing through the lens bends and passes through the principal focus. So this length between the optical center and the principal focus is the focal length B. Number 3, it passes from air to glass whose refractive index is given. We will use the law sine n is equal to sine I over sine R. N replaces sine R. And we do the calculation. And this gives us the value 1.5 sine 57 over 1.5. So this angle here is calculated. Now we have to consider this angle and then using the refractive index calculate the critical angle. Is this angle is greater than this angle? Sorry, this angle gives you angle of incidence here. So if this angle is sine 57 over 1.5, that should give you some angle. And then there will be a triangle here. So use the sum of angles in a triangle 180 concept and calculate this angle. So if this angle is greater than the critical angle 42, it should totally internally reflect. So this means that the angle of refraction that calculated here will be 34 and the critical angle will be calculated here is 42. I have just explained something which is extra to the question. The angle of reflection will be 40 and the line PQ is a normal. So number 5, you have to consider all 3 rays falling on this lens, and this lens is bringing them together, converging them. So this is a converging lens. This lens, number 2, is also bringing them together, converging them. So converging lens again. Number 3, this lens, the rays originally was going like this. It is making them moving away from each other. So it is diverging them. So this is a diverging lens. Which expression for refractive index? Well, it should be the angle of incidence. Oh, sorry, the ray is coming from here. So this is the angle of incidence W and this is the angle of refraction Y. So sine W over sine Y should give you refractive index. A tricky question, we have to calculate X. We don't have to calculate the angle of refraction, but we need the angle of reflection. So we use this to find angle of reflection, which is 28. And then we know that because this is a straight line, so vertically opposite angles, this will also be 45 because this will be 45 and this is 90. So from 45, we take away 28, that gives us 17. When we use a converging lens as magnifying glass, we get a virtual and erect image. This is from our knowledge, so no need to worry about any other thing. Number 9. So it says angle of incidence at y is greater than the critical angle. So here, the angle, well, the condition for total internal reflection has met. So it's going to go this way. Why it's not going here? Because this means the reflection is not taking place. So this means reflection is taking place. Number 10. So if C is the critical angle, it should go like this. Remember, at critical angle, the sum of the rays reflect and some make a 90-degree with the normal. That's the identifying mark of a critical angle, these three lines. Number 11, red light and blue light. How you do it? You do the Roy-G-Biv term. So R comes first, its wavelength is longer than the blue one. All others are wrong. Number 12. So we have refractive index, we have angle of incidence. So the angle of refraction will be very simple through this calculation. Number 13, converging lens is used as a magnifying glass. So the object and the image will be larger, upright. That's what we're looking for. A mirror makes the image at equal distance from the object on the other side. So B is where the image is formed. We see image from here at this point. Number 15. So what is a possible critical angle for light? So this is where the critical angle is met, total internal reflection taking place. So the angle will be 45. Why angle will be 45? Well, we look at it carefully. Possible critical angle, because this is a tricky question. So if you consider this is refracting, this is refracting, this is totally internally reflecting, it does not mean that this is the critical angle. Critical angle is smaller than 50. Remember this thing, critical angle is smaller than 50. So it can't be 15 because otherwise this would have totally internally reflect. It can't be 30, otherwise this would have done the same thing. Can it be 60? No, because then it wasn't going to be TIR here. So the only possible thing is 45. Number 16, a short-sighted eye. The position of the image is in front of the retina, not behind retina. So it is short of the retina. That's why it is called short-sighted. Remember, short-sighted means the image is short of the retina, in front of the retina, not behind retina, like this. And the lens needed for correction, well, we have to take it further on the retina. So we use diverging lens, which separates, which um, makes them go a little bit wider. So they meet at the retina. That's why. Here, very tricky question. Read the question carefully. The length of the mirror is 50, and this length is h. Customer's height 150, so his eyes at 150. To see his feet in the mirror, he must be halfway between eyes and feet. Why? Because the half of 150 is 75. And at 75, which is the halfway, the angle of incidence from the feet will be equal to the angle of reflection to the eye. Okay, so if half here is 75, that means this is the half of the mirror. So the bottom half of the mirror becomes 25. Upper half 25, bottom half 25. So if bottom half is 25, that means the height above the ground should also be 25. So 75 means you have to have 25 from the bottom at least. Okay, so that makes it 75 maximum height of the mirror. It can be above that, but it has to be at least 75 from the bottom. So if it is 75 at the bottom, that makes it, so even if this is the point where 75 is the last point of the mirror, so he can still see his feet. So the maximum height has to be 25 h. If it is more than 25, okay. If it is less than 25, this total height will be less than 75. So that means the person cannot see his image. So that's why the smallest value of h has to be 25. Number 18. So it is the critical angle, and the critical angle is the angle that is 90, which is the reflection. Reflection is taking place. The reflected ray makes a 90 degree with the normal. So angle is 90. So sine 90 goes here. Why sine 90? Why sine R is on the top? Because the medium and the vacuum. The medium has a density more than the vacuum. So we use the sine I over sine R in the reverse way, sine R over sine I. Secondly, the angle of incidence, well, look at 60. If drawn normal here, this angle will be 30. So that will be the angle of incidence. So this is the correct correct expression for this. Number 19. The image formed by the lens. Look at the boxes, number of boxes. The focal length is 1, 2, 3, 4. And the image is 1, 2, 3, 4, 5, 6, 7. So it is between F and 2F. If it is F and 2F and this is 2F, then the image will be formed. Well, there is some misprint. This point is Q. Okay, so the image will be formed. If it is between f and 2f, the image is formed beyond 2f. Remember the 5 settings we have studied? If the object is at 2f, the image is also at 2f. If the object is beyond 2f, the image is between f and 2f. If the object is between f and 2f, the image is beyond 2f. So it will be to the right of the Q. Again, the Q is missing here. Consider this point as Q. O, F, Q. So the image will be right of the Q. Number 20. So the lens here in the camera is always converging and the image is always inverted. That's how we get images in the camera, but these cameras are not in use anymore. We have digital cameras. 21. The refractive index of the plastic, this plastic, and the critical angle. So critical angle must be less than 70, allowing light to TIR, and the refractive index, if this is 1.4, this has to be greater than 1.4 so that the second condition is met. Remember, TIR means in a denser to less dense medium. Sorry, critical angle definition in a denser, when a light travels from a denser to less dense medium such that it makes 90 degree to the normal, it totally internally reflects. That's why this has to be a denser medium. Its density, more density means its refractive index must be greater than 1.4. These two are the logics used to answer C. Remember these two logics carefully. A vertical plane mirror always forms a virtual and erect image, not inverted. Number 23. We're giving the refractive index, we're given this angle. This is not angle of incidence. Angle of incidence will be 60. And this calculation seems wrong. Remove this, just do it yourself. So we will be using the angle of refraction equal to sine R equal to sine I over 1.5, and sine I is 60. Answer should be 35. Look at this. This was wrong because the answer was coming at 20. That is wrong because it here it has been used as 30 angle of incidence, which is wrong. Converging lens, focal length between these 2 points. If you want to produce a real image here, it is 2 focal lengths, so it should be 2 focal lengths. It should be placed at A. Again, 5 settings of the converging lens. So this is the one of the setting. Object at 2f, image at 2f. And remember, this is what we used in a photocopier. The only obvious thing for an optical fiber, it has to totally internally reflect. So that's why this one here. Let's consider other ones. You can see clearly none of them are exhibiting I equals R concept. Only this one. If you place a normal here, I should equal R, all these, at all these TIRs. So the lens that is making the rays go away from each other is a diverging lens. So what is happening here? A refraction going away. Angle of refraction, let's see. So the angle of incidence is 45 sine I over n gives you refractive angle of refraction 23. Just make sure you're familiar with how this answer is converted into this using sine inverse operation on the calculator. So here we can see, and we have to find angle of incidence, for which we need to resolve this. So if these two angles are equal, which are equal, why they are equal? Because the line is a straight line, okay? And at this, for this straight line, this angle is given as 80. If this angle is 80, what is this angle? So this angle here is 90. Okay. So if you half this 80, why are you halving this 80? Who tells you that this half is 80? Well, because of the 90 degree here. 90 degree here will make it 40. So this angle will become 40. That means the angle of reflection will become 50. 90 minus 40, 50. And angle of reflection 50 means angle of incidence also 50. So 50 and 50. Number 30. Angle of reflection using angle of incidence and n is again calculated very carefully. Use the sine inverse identity here. Put sine inverse. This value should give you 26.1, approximately 27. Well, to be honest, it is not 27 that is wrong. It is 26. So the answer is 26 given here. So if this is 40, the angle of incidence will be 50 because the angle of incidence is the incident ray makes with the normal, and the normal is at 90 degree with the mirror. That gives 50. Angle of incidence 50 means angle of reflection also 50. 50, 50. 32. This is the angle which is the critical angle because at this angle it is TIR. Man is short-sighted. Here, short-sighted means short of retina. This is the retina and this is the image, short of retina. This not possible. This correct sight. This long sightedness. So this is only short-sighted. The object placed at O. Let's see why B, C, and D are wrong. The image is inverted. It's not possible in mirrors. The image is made on the mirror, not possible. And the image is inverted on the mirror, not possible. Only possible is A. Choice A. We have 35 detailed diagram, scale diagram question. So scale diagram questions can only be done in real. They can't be done on images. But the formula to calculate magnification is the height of the image. So you take a scale and you calculate, you measure this height. Also carefully look at these. So 1, 2, 3, 4, 5 boxes represent 1 centimeter. So you can also, you don't need a scale actually for the second approach. You can count the number of boxes 1, 2, 3, 4, 5, 1, 2. So if 5 boxes is 1 centimeter, 7 boxes will be how many centimeters? Then calculate the number of boxes here or use a scale and then put them in the value in this formula. The answer should be 2. A plane mirror always produces virtual image, has to be same size as the object. Which diagram shows partial reflection and reflection? This is reflection. All this is reflection as well. So reject A and B. No reflection is taking place here. But here, there is no partial refraction. This is a complete reflection. Why this is a complete refraction and this is partial? Because look at the rays. If the ray coming is going this way, it's not going to totally internally reflect. It has to be very close to this line to do TIR. That's why this is the correct choice. Again, we have a scale diagram. Measure it with the scale. Use this. You should get 3 as the magnification. Very simple. You need X and Y equal for reflection to take place. And this is a tricky question, but we will look at it in detail. In A, it is correct because denser to less dense medium, the ray goes away from the normal. This, why it is not correct? Very good. This why this is not correct. Look at this. It is coming at 90 degrees. It is going straight. And it is totally internally reflecting. Well, how about if this angle was greater than the critical angle? Well, if this angle is greater than the critical angle, it should also show a ray here, which is partial, which is a critical angle, and it should show a ray here. This is not showing a ray here. That's why. So this one, again, it is coming from denser to less dense, and it's moving away. It is correct. Now look at this one. This one here, it is moving away. It is moving away from the normal. It is coming from denser to less dense. And then from here, it is moving towards the normal. The both are wrong. That's why D is not correct. Properties of the image, it has to be a virtual image because of the diverging lens always produces virtual images. And look at this object and image will be here. So image will be smaller than the object. 42. Which graph is correct? B and C are rejected because of the reason that sin I and sin R are always linearly proportional to each other, directly proportional to each other. Sin I increases, sin R increases. That means angle of incidence and angle of reflection. When you increase, look at this diagram. You start from here, the rays coming at 0 angle of incidence goes at 0 angle of reflection. You increase the angle of incidence slightly, this ray will slightly move this way. So the angle of reflection will also decrease. I will increase, R will increase. B and C is inverse relationship. If when I is decreasing, R is increasing. I is decreasing, R is increasing. Reject this. Now look at A and D. So in A and D, they are confusing, and you will be well confused if you don't remember that I is always greater than R. I cannot be less than R. If I is less than R, then this relationship, look at this. I is greater than R. It is clear in the diagram. So here in D, I and R, so I is smaller and R seems greater. So when we increase I by this, R is increasing more. That's why we have rejected this one. So this one, well, it's left as the only choice, but it is correct because when we increase I, the R is increasing less. If you look at this, look, we draw a line at 0.5. It's not meeting 0.5, it is above 0.5. Now here, draw a line at 0.5, it is less than 0.5. So increasing I by something less than 0.5 will increase R more than 0.5. So I will not be greater than R. Here, increasing R by something like more than 0.5 will increase R 0.5. That means I is greater than R. The boy looks at the mirror. The girl is standing in front, whose image is made here, and the boy sees the girl here, which is coming from here. So this is the image of the girl. Where does the boy see the girl's image? Here. It is here that the boy sees the image. So the convex lens are used in cameras and as magnifying glass. Two applications are mentioned, and both, well, in camera we have a real image, but in magnifying glass we have a virtual image. We know this from the 5 settings of the lens. Letters appear in front of the boy, the student. What should student see in the mirror? So if the student looks into the mirror, it will be like this. The mirror will make something. So this is not the mirror, this is the image. Imagine you have this in front of you and the mirror is on your back. You turn towards the mirror. When you turn towards the mirror, this will be on your left. So this is your left. This will be in the middle, and this will be on your right. So this is your right. So this will be on the image on the mirror. On your left will be F, and on your right will be T. Okay, if you cannot work it out like this, reject the wrong options. C and D are wrong because images in the mirror are not upside down. And look at this. Can you make an image like this? Obviously, F will not change its position towards O to make F O T. So reject this one. This is the only choice left. So if you cannot work it out like this, just work it out like this. This is called elimination. So choice choose by elimination method. You reject the wrong choices, you eliminate the wrong choices until you are left with only one. Even if you don't know right or wrong, you still have that one strongly based on the knowledge. You should know why you are eliminating, and you should eliminate correctly to have left the remaining, which should be the last choice, and it has to be correct. So we have to find the refractive index of the plastic. We have angle of incidence 28, angle of reflection 45. Remember, the angle that is used here is reflection on the numerator, and reflect angle of incidence as the numerator because it is a denser to less dense medium. So that's why we will use this sine 45 over 28, 1.51. That is the refractive index. 47, angle of incidence, refractive index, angle of reflection in the calculation. So carefully look at strikes the surface of glass. So it is coming from something like air and it is coming into the glass. It has to be sine I over sine R. R is replaced by N. N is going here and sine R here. That gives you 28. Again, and again, and do not forget to use the sine inverse on the calculator. Number 48, concave, i.e. diverging lens. Correct description will be virtual upright diminution. We should know this from our knowledge. So critical angle has to be B. It is not A because at A, TIR is taking place. That means critical angle has already been met. At B, it is not TIR, but it is making 90 degree. Remember the definition of TIR. When the angle of incidence is greater than the critical angle, then TIR takes place. It is not TIR. It is just a line refracted ray which is making 90 degree with the normal and it is meeting the specification of critical angle definition. Number 50, the image will be at P and it will be virtual. We should know this from our knowledge. Critical angle of the light in the glass. Again, it is TIR here. It is not TIR, sorry, it is making 90 degree. So D will be the critical angle. So the position of the image for this object in front of a diverging lens will be this. Why? Just draw the line here, bringing back through F, then draw the line here like this and first of all, draw the line here and bringing back through F. The second line goes from the center, optical center. The point of intersection of the two rays, two lines, will be your image stop, this here. This question is, well, we haven't practiced and it's not in our syllabus. It has just been asked by someone, extraneous person. So let's take this opportunity to understand how these questions give us the value required. We are given the distance of image and object in centimeters, given in the scale. We are given the height of the image. We have to find what we have to find. Focal length. Height of image given, height of object given, all the data given. This is the formula for a converging lens. Look at that, converging lens. Remember this formula. Okay. So put the values here. The answer is -3. -3 is not in the choice. 3 is in the choice. Okay, we go for it. Carefully understand how we have substituted the values and then we have taken F upside down. So F is a reciprocal. 1 over F's reciprocal gives us F. So what is taking place here? Deeper region to shallow region. The frequency does not change and the speed changes. We have done this in previous chapter as well. So this is a tricky question. Look at all of them. Okay, first glance, I don't understand how to do this. Let's go back to our knowledge. We know that the angle of incidence This is a mirror. Angle of incidence has to do something with it. So draw the angle of incidence. Here, not equal. Both angles are not equal. Draw a normal here. Okay. So both angles, well, they will not be equal. This might be equal. This is not equal. If you draw it carefully here. If you draw here, you can clearly see that the angle of incidence and angle of reflection will be equal. Angle of incidence and angle of reflection will be equal. So that's why we choose this choice. So this question, a boy is looking into a periscope. Periscope uses two mirrors, both placed at 45 degree with the walls. So how does the boy sees the image and how which diagram is correct? So first of all, it has to go straight to bend straight, right? Angle of, so if this is mirror, the angle of incidence should be equal to angle of reflection. Look at this, look at this. In both, this is not taking place. So what is wrong in this one? So the eye does not send the ray, eye receives the ray. Okay. So if eye receives the ray, it means the D is wrong. This one, the eye is receiving the ray and the angle of incidence and reflection are both equal, and that is why this is the correct diagram. When light passes from glass, which is denser, to less dense, its wavelength increases because its speed increases. Denser to less dense is just like shallow to deep water. The angle of reflection here is by intuition 60 and 60. Lens blurred in front of a screen. How can it be brought focused on the screen? Well, let's look at all the options. Can you do it by moving object away from the lens and the screen? So if you move the object here, this will also move this way. By moving the screen away from the lens and the object, so moving screen doesn't make any difference because the image is already been made here. It's not going to change the image. By using a brighter object, no. By using a lens of longer focal length, okay, that's interesting. So if you have a longer focal length, that means image will be made slightly further from the object, from the mirror, from the lens. So it will be on the screen. So D is a very good choice. Well, it is difficult to understand, but you have to practice these questions so you remember them. That's another strategy. Here, another tricky question. So, how many students can see each other? In order to see each other, the students must have the others in their line of sight. So the student is sending ray here to see this image. Yes, possible because angle of incidence, angle of reflection equal. Now this one, to see this one, it has to send a ray here so that, sorry, it has to receive a ray from this one. I said that one wrong as well. Let's do it again. Student Y sends a ray that should reach student X, making an equal angle of incidence and reflection possible because if it sends here, go here. So he can see at least one student. Student Z sends a ray in the middle that goes into the eye of the X. So X, Z is also visible to X. So if X can see both, so Z can see both because they're both at the same distance. Now consider student Y. Student Y, Z sends here to reach student Y possible, X sends here to reach Y possible. So all three students can see each other in this arrangement. Thank you. Human eye converging lens. This is an image at the back of the eye. Eye views a distant image. What type of image is produced? It is real, it is inverted, and it is diminished. You might be surprised why we don't see things inverted. Well, it is the optical nerve that takes the image inverted to the brain and turns it upside down. The blessing of the Almighty Creator. 62. Lot of data is given. Well, you can see the focal length, 6 centimeters. Anything between the focal length, within the focal length, will be producing a virtual image. Reject A and B. A virtual image in this has to be erect. So reject D. So C is the choice. So we see X and Y should be equal. Yes. And we see D1 and D2, D1 and D0, DI and DO should be equal. Why? These two are the laws of reflection. So C is the choice. Has he drawn the correct image? Well, correctly drawn image is at X, not at F, because it is magnifying glass. So here, when you go from deep to shallow, you move towards the normal, and your wavelength decreases as well because of the shallow water. We have discussed this before. So the eye is the observer. There is a pin. Where is the image of the pin? It's right here, because the image sends a ray straight to eye, which is visible at D. So we have an object. Where is the image? Well, goes here, go through F. Second one go through the optical center. They both meet at this point. This is where the image is. Which one is not possible? This is possible, very good possible. This is possible, this is possible. They're all refraction taking place. What's happening here? Well, very strange. We have a ray coming in, the ray is refracting, okay, and then the ray is totally internally reflecting. Well, if it was totally internally reflecting, why the angle is such a small angle? That's why it's going this. And also, if it is totally internally reflecting, it's going to go like this. And here, so look at this. This is where you should learn things. This is the point. If this angle of critical angle is such a small that it is totally internally reflecting here, it should also totally internally reflect here. So it should come here. That means this angle, which is far, far greater than this angle, is still not greater than the critical angle. So everything is just wrong. It looks like a child has drawn this diagram. So this is wrong. The real images by converging lenses are always inverted. Reject B because they are not on the same side. Reject C because they can be shown on the screen, and reject D because they can always be seen by human eye. The image is at B. Thank you very much. I hope you are enjoying all of these videos. I think I do deserve to be subscribed and get your like.